If you find it difficult to get your head around word problems, then the bar modelling method is a really good way of visualising the word problem so you can work out exactly the maths that you need in order to solve them. So let's start with quite a simple example. This question says, Betty and Doris have 246 marbles altogether. Betty has 102 marbles. How many does Doris have? So when solving any word question, what you need to do first is work out what you know and what you don't know. So I know that altogether there are 246 marbles because it tells me here, and I know that Betty has got 102. So with my bar method, I'm going to draw a rectangle, and then I'm going to start marking this off. So this represents the whole thing all together, represents 246 marbles, because that's how many marbles there are all together. And I know that Betty, I'm going to do Betty in blue, so Betty has got this many marbles, and this represents the 102 that she's got. So now I need to look at this again. So I know that there are 246 marbles altogether. I know that Betty has got this proportion in blue, and so this should make it easier for me to see that what I need to do in order to answer the question, this portion here in green must represent what Doris has. So, what calculation do I need to do in order to work out this difference? Well, I know this. I've done lots and lots of practice. I know that when we're finding the difference, I need to subtract. So, I can do my calculation over here. So, 246 take away 102. 6 take away 2 is 4. 4 take away nothing is 4. And 2 take away 1 is 1. So, how many does Doris have? She has 144 marbles. So this one's a little bit more complicated. The total cost of a scooter and 2 motorcycles is £9,798. The cost of a scooter is £2,654. How much does one motorcycle cost? So again, I'm going to look at the question and work out what I know and what I don't know. So I can see that I've got a total cost here, and so that's what I'm going to draw with my bar. So the whole total cost of a scooter and a motorcycle is £9,798. What else do I know? I know that there is one scooter, which I'm going to mark over here in green, and I know that there are 2 motorcycles. So this is a motorcycle, this is a motorcycle, and this is a scooter. What else do I know? I know that a scooter costs £2,654. So this portion of my bar represents £2,654. Okay, so if I stand back and have a look, can I do any maths yet? Yes, I can, because I can actually get rid of this part by finding the difference. So 9,798 take away 2,654. 8 take away 4 is 4. 9 take away 5 is 4, 7 take away 6 is 1, 9 take away 2 is 7. Okay, so this portion here, what's left is £7,144. Have I answered the question yet? No. So if I look back up here, it says how much does one motorcycle cost, and I know that 2 cost £7,154. So I need to do something else, and I need to do a quick bit of short division. So I'm going to get rid of this so I've got a bit more space. Obviously wouldn't actually do this in my book. So £7,144 divided by 2, because I need the cost of 1. So 7 divided by 2 is 3, remainder 1. 2 into 11 is 5, remainder 1. 2 into 14 is 7. And 4 divided by 2 is 2. So the cost of one motorcycle is £3,572. And I could double check this by adding 3,572 plus 3,572 plus 2,654, and that should give me my total score at the beginning. So hopefully you're beginning to see that although drawing the bars in this way doesn't actually help you solve the calculation, it does help you see the problem in a slightly different way, in a more pictorial way, which can help you work out what to do next. So let's have a look at this example. We've got Emma and Claire each had the same number of sweets. Emma ate 25 sweets and Claire ate 31. Emma was left with twice as many sweets as Claire. How many sweets did each girl have to start with? Okay, there's a lot of information here, and so this is where the bar model can really help. First of all, I need to look at what I know. I know that there are 2 girls in this maths story, and so I'm going to draw them, both the bars, and do Emma and then Claire in green. And I'll put their initials here so I remember who is who. So Emma and Claire. Now I've drawn the bars the same size because I know from the beginning of the story that at the beginning of the story Emma and Claire each had the same number of sweets. However, they ate different amounts. I also know that Emma at the end was left with twice as many sweets as Claire, and so I'm going to put this on my bar too. So at the end of my math story, if Claire had this many sweets left, Emma had this many, because Emma had twice as many left at the end. Okay, what else do I know? Well, I can also see that what is left in my bar, so here and here, is what both girls ate. Now I know how much they ate because it tells me in the question. It tells me that Emma ate 25 and Claire, down here, ate 31. Now they must both have eaten the same amount at one point. So if this is 25 that Emma's eaten, well then Claire must also have eaten 25. So this is 25. What I need to work out is what is here, and I can do that by looking at the maths I've got. If they both ate 25 and I'm looking at what extra Claire ate, because she ate more than Emma did, I know, again, using my difference skills, I know that the difference between 25 and 31 is 6. And so if this amount here is 6, then this is 6, and this is 6, and this is 6. And now I've got all of these blocks filled in, I can answer any of the questions. And the question is how many sweets each girl had to start with. And that's a simple case of adding. So if I start with Claire, ate 31 and had 6 left over. So 31 plus 6 is 37. And just to be on the safe side, I'm going to double check, because if I've done my maths correctly, then Emma's should add up to the same thing, because they both started with the same number of sweets. And so I know that 6 plus 6 is 12, and I know that 25 plus 12 is 37. So the girls had 37 sweets each to start with. Okay, one more. Sam had 5 times as many marbles as Tom. If Sam gives Tom 26 marbles, the 2 boys will have the same amount. How many marbles do they have altogether? Now again, I've got a lot of information here, and like the last one, I know that there are 2 people in my story, both Sam and Tom. So let's look at what I know. I know that there's the two boys, and so I'm going to put Sam on this bar and Tom here. Now Sam had 5 times as many marbles as Tom. So if Tom has that many marbles, Sam has 5 times as many. 3, 4, 5. Okay, what else do I know? I know that if Sam gives Tom 26 marbles, very generous, the two boys will have the same amount. How many marbles do they have altogether? So I need to look at my bars. So Sam has got 5, Tom has got 1. How many of these bars, of these blocks, do I need to give Tom so that he has the same amount? Well, I can see that if I move these 2 blocks down here, then Sam and Tom will have the same number of blocks each. The question is, how much these blocks represent? Well, I know that Sam is planning to give Tom 26 marbles. So these 2 blocks are 26 marbles. So how much would 1 block be? Well, there are 2 of them, and I know that half of 26 is 13. So that means that this is 13, and 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 this is 13. So if I look back at my question, it asks me how many marbles do they have altogether. So what maths do I need to do? Well, now my blocks are filled in, I can see quite clearly that I've got 6 blocks that are all the same size, which means I definitely have to multiply, and I need to do 13 times 6. So quick bit of short multiplication, 3 times 6 is 18, 1 times 6 is 6, plus 1 is 7. And so how many marbles do they have altogether? 78. So I hope you find that helpful. Keep practicing it. There's loads and loads of examples of this online, and as I say, it won't help you with the calculations, but it might just help you to picture the problem.